All right, let's look at the homework 10.5, problem number 7. All right, so we have this given function, f of x, 1 over is equal to 1 over x plus 1. And we're going to use the fifth degree Taylor polynomial, and we want to find the error bound. All right, so let's do that. All right, so by Taylor remainder theorem, we know that R5 is sixth derivative evaluated at some z between 0 and 1/3 divided by 6 factorial, and then you have x minus a, actually center is c, to the 6th power, right? So we have that. So in this case, let's see, x is going to be, so center is 0, and the largest possible x would be, so we're going to try to, so we have R5, and we want to find upper bound, right? So here, so we're going to try to find the biggest possible value, so we know what to plug in, so let's do that. All right, so 6 factorial is a number, so we can't really change that, so put that in there. All right, so c is 0, so we have 0 to the 6th power. All right, so center is 0. All right, x can move between 0 and the 1/3. So to make this quantity as large as possible, I'm going to move away from the center as much as possible. So in this case, 1/3 would be the one. Right? Then we just have to figure out what would be the biggest possible, so upper bound for this quantity. So what's the value of this guy in the worst case scenario, right? So, or best case scenario, right? So here, let's compute that. So we know that f prime is going to be, we have to take the derivative. So this is, first I'm going to rewrite that. So this is, I don't like a fraction. So it's a quantity x plus 1 to the negative 1 power. All right, if you take the derivative of that, put the negative 1 in front, x plus 1, and subtract 1, and multiply by derivative inside, which is 1 anyway, so this is that. All right, we need the 6th derivative, so we take another derivative. Second derivative would be, put negative 2 in front, so it's a 2. X plus 1 to the negative 3. All right, another derivative. So this is the third derivative. So that's going to be negative 6. X plus 1 to the negative 4. And this is the fourth derivative. So this is going to be 24 quantity x plus 1 to the negative 5 power. All right, fifth derivative. All right, so it's going to be negative. So 5 times 4 is 20, so it's 120. X plus 1 to the negative 6. All right, we need the 6th derivative, so you have just another derivative. So this is going to be, so it's going to be positive 0. 2 times 6 is 12, and so it's a 720. X plus 1 to the negative 7th power. All right, then we're talking about the largest possible value. All right, so we can plug in any number between 0 and 1/3. All right, so to make this, let's see, maybe I should write it this way. So you have a 720 over. All right, so you actually have x plus 1 on the bottom, right? All right. So to make this value as big as possible, what you want to do is you want to make the denominator as small as possible. So the best case scenario would be x is 0, right? If you put 0, that's the smallest. So this is going to be less than or equal to 720 over, I plug in 0, so it's 0 plus 1 to the 7th power, which is just a 720. All right, so this is the upper bound for sixth derivative of f. So we put that in here, right? So whatever this is, maybe I'll simplify a little bit. You have a 720, and then you have a 6 factorial on the bottom, and then you have to multiply by, so you have a 1/3 to the 6th power, so it's going to be 3 to the 6th power on the bottom. All right, let's compute that value using Geogebra. All right, so I'm just going to type in 720 divided by 6 factorial times 3 to the 6th power. All right, so that's the value. All right. Oh, so I want, let's see, if you click right click and object property, right, then you go to algebra, right. If you put click on uncheck the symbolic, it gives you a decimal value. Actually, we need better precision. So we need, let's see how many, 4 decimal places. So we're gonna do go to option, rounding, and change it to 4 decimal places. All right. So the value came out to be 0.0014. All right. So let's put that in. All right. So that will be the error bound for using Taylor polynomial of 5th degree. All right. So let's type it in. All right, we have 0.0014. That will be the error bound. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.